Welcome to the last couple topics of the year, guys. We're going to talk about polar functions. In section 9.4, we're just going to talk about the polar coordinates and what the graphs look like. And then in 9.6, we're going to talk about the area. So today, 9.4, polar coordinates. Polar coordinates are a different way to write a function in a plane, kind of like parametric and vectors. The way you do it is you measure the point based on how far it is away from zero and how much of an angle it's gone. So the points aren't x comma y, they're r, how far away it is from zero, and theta, how much the angle is opened up. They're parametric graphs, they're polar graphs, and it looks really easy because it looks like you're looking down on the Earth from the North Pole. So this would be the point 3 comma pi over 3 because it's 1, 2, 3 radius and it's pi over 3 around. This would be the point 1 comma negative pi over 6 because it's 1 and you've gone down pi over 6. 2, 3 pi over 4. Sadly, they're not going to let you use those. You're going to have to figure out how to draw them on a regular graph. So we need to be able to convert from polar coordinates to rectangular coordinates. Here's some basic information you need to know. R squared equals x squared plus y squared. And then this basic information. Really the information you need is this. X equals r cosine theta. Y equals r sine theta. Tan equals y over x. And r squared equals x squared plus y squared. We will use those 4 pieces of knowledge to convert between polar and rectangular coordinates. Let's convert 2 comma pi to rectangular. Well, 2 means the radius is 2 and pi is over here. What does that point look like? It looks like it's negative 2 comma 0. So let's prove that 2 comma pi is really negative 2 comma 0. Well, the x value is r cosine theta. That means that x equals 2 cosine pi. Well, cosine of pi is negative 1. That's negative 2. Y is equal to r sine theta. R sine theta. Well, sine of theta is 0. Sine of pi is 0. So that is 0. So that's really easy. 2 comma pi is negative 2 comma 0. Going from polar to rectangular is pretty easy if you know the r sine theta and r cosine theta. But how about if we go backwards? So there's a coordinate in rectangular form. Let's convert it to polar. So the first thing I need to know is that tangent of theta is equal to y over x. So 1 over negative 1. So negative 1. So tangent of theta is negative 1. When is tangent of theta negative 1? What angle has a tangent of negative 1? 3 pi over 4. Yeah, you have to know your unit circle. So that's the pi part, or the theta part. How do I find the r part? I know that r squared equals x squared plus y squared. So r squared is negative 1 squared plus positive 1 squared. That's 2. So r equals the square root of 2. My polar coordinate, r theta, is square root of 2, comma, 3 pi over 4. And that's it for section 9.4. Polar coordinates to rectangular coordinates to polar coordinates. Next time we'll talk about the area between these functions, and that gets a little bit more difficult.